Welcome to Naradar Academy. In this video, we are going to discuss about limit of a function on the complex plane. So first let us start with the definition of limit on real line. See, in real line, we consider a point x0 and a neighborhood of this point. Neighborhood means what? The points which are at a distance of delta from x0. So, both on left and right side, we take points at a distance of delta. So, this is x0 minus delta to x0 plus delta. So, this is a neighborhood of x0. Okay. So, this is the point on the domain. So, for these points on the domain, we write the images along the vertical line. That is, along the horizontal line, we take the values of x. Along the vertical line, we take the values of f of x. Now, along this vertical line, you mark the image of this neighborhood. Okay, suppose if the image of this neighborhood lies completely within this small interval, which is neighborhood of some point L, then we say limit x tends to x0, f of x is equal to L. That means first we take a point x0 in the domain and we take a neighborhood x0 minus delta to x0 plus delta. Neighborhood means what? The points which are at a distance delta from x0. So it can lie on both sides of x0, either on the left side or on the right side. So this is the neighborhood of, this is one of the neighborhood of x0. So for this neighborhood, we find out the image under f. So the images are marked along this line. So if all the images are lying in a small interval like this, where L is a point and L minus epsilon to L plus epsilon is a small neighborhood of this L. If the image of this interval completely lies within this interval, then we say that limit x tends to x0, f of x is equal to L. That means whenever x is approaching x0, here, then f of x approaches L in the range. Okay. So this is the definition of limit in real line. This is how we define. Here domain is a single line that is taken along the horizontal line and the range or codomain is taken along the vertical line. So we mark everything in a single plane. Okay. And here the neighborhoods are open intervals, because if you we are taking the points along a line, no. So here the neighborhoods are what? Open intervals. Neighborhood of x0 is x0 minus delta to x0 plus delta, and neighborhood of L is L minus epsilon to L plus epsilon. So this is how we define, and mathematically we write it like this. Modulus of f of x minus L is less than epsilon whenever mod x minus x0 is less than delta. Okay, so this is the definition of limit in the real line. Whenever this limit exists, it is a unique limit. You cannot have two or more limits for a single function. Okay, that we don't call as limit. If limit exists, it is always a unique limit. Now let us come to the case of complex valued functions. Okay, in complex valued functions, we take domain as z plane. Here, because we have real axis and imaginary axis, no. So for defining the domain itself, we need one plane. That plane is called z plane, and the image of all these points here in the z plane are denoted in the w plane. Okay, this is called codomain, right? So here also in the same way, how do we take in real axis? In the same way, we are taking in z plane. I am taking a point z0 here. I am going to consider a small neighborhood of z0. Since this is a plane, you have to take neighborhood as a small circle with z0 as center and delta as radius. How did you take in the real line? With x0 as center, you move delta steps backward and delta steps forward. That will give you the neighborhood in the real line. In the same way, for complex plane no, it's a plane, no. So you can move delta distance in any direction. Okay, not only in the left and right. Here I can move only along left and right because it is real line. Here it's a plane. For delta distance means I can move on any direction. So if I collect all the points, I will get a circle, right? So whenever we consider a small neighborhood of z0 which is of radius delta, find out its image in the w plane. Okay, then if all the image of all the points of this neighborhood completely lies within the neighborhood of this L, then we say limit z tends to z naught f of z equal to L. That means all the points in this neighborhood will also lie closer here, closer to some point L. In that case, we write limit z tends to z naught f of z equal to L. Understand? Right. Now, here mathematically, how do we write? Modulus f of z minus L is always less than epsilon whenever this condition is satisfied. Z minus z naught is less than delta. See, here there is a huge difference between doing problems in real line and in the complex plane. In real line, approaching x naught is possible only in two ways. Either you can move from the left or you can move from the right. Okay, so for doing problems in real analysis, you have to take left limit and right limit. That means you are approaching x naught either from the left side or from the right side. Okay, both should be equal to the value of f of x naught. Then we say the limit exists. And similarly here also, you can approach either from left or from right. That is, minus epsilon is taken to be left and plus epsilon is taken to be right side. Only two possible ways are there, and both, when you approach along both the sides, the value of the function should be same. In that case only you say the limit exists. But where in complex case, you have infinitely many ways of approaching z naught. See, this is a circle, no? So you can approach z naught along any way. Okay, along any way. Infinitely many ways are possible. So here for doing problems, whatever way you reach z naught along any way you can reach z naught, in all the ways it should have the same value. Then only we say the limit of the function exists. So that is what I have written here. For real numbers, a point x naught can be reached only in two directions, either from the left or from the right. So if both the left side limit and right side limit are equal, and it is also equal to the value of the function at that point, then we say the limit exists. For functions of complex variables, infinitely many modes of approach are possible, and the value obtained in all the ways should be equal. Then only we can say what? The limit of the function exists in case of complex plane. Okay, now let's see some problems of finding limit of a given function. See, this is the first problem. Find limit z tends to 2, z square minus 4 by z minus 2. See, if you substitute the value z equal to 2 directly here, what happens? 2 square is 4, no? 4 minus 4 by 4 minus 4 is what? 0 by 2 minus 2 is what? 0. So 0 by 0, indeterminate form, no? So you should not write in that way. So whenever you have a problems of this type, first you substitute the limit as it is in the given problem. If you get the indeterminate form 0 by 0, you cannot write the value as it is. So you have to try to eliminate that 0 by 0 form. So for that, what I am going to do is, look at this term here. This is like a square minus b square, no? That we can rewrite it as a minus b into a plus b. So this z minus 2 term get cancelled. So finally what I am having, limit z tends to 2, z plus 2. So now there is no problem. I can directly substitute the limit. So substitute z equal to 2. So 2 plus 2 equal to 4. So what is the value of the limit? Equal to 4. So what are we actually doing here? See, this is the function. This is the function defined in the complex plane. As it is, if the function is as it is like this, I cannot find the value of this function at z equal to 2. Because if you substitute z equal to 2, what will happen? It will become 0 by 0 indeterminate form. So when you have cases like this, when the function does not explicitly have any value at a particular point, you have to find its limit value. That limit may exist or may not exist. Okay, but we are trying to find whether the limit exists there or not. Okay, so what we are doing here, just a mere simplification of the terms given in order to avoid that 0 by 0 form. So the value of the limit at 2 is equal to what? 4. Okay, next problem. Find limit z tends to minus 2i z plus 3 into z minus 4 by z square plus 5z plus 9. Right? Okay, now let's see whether by substituting this minus 2i, whether it reduces to some indeterminate form or not. If it is not coming as 0 by 0, you can find the limit directly. Okay, no problem with that one. So here z plus 3 by z minus 4 into z square plus 5z plus 9. So by looking at this, we can surely say it is not in 0 by 0 form. So let us try to substitute this value for z. So first let us multiply the numerator. Z plus 3 into z minus 4 will become z square minus 12 minus 1z divided by z square plus 5z plus 9. Now let us substitute z equal to minus 2i. So here it is what? 4i square minus 12 plus 2i divided by 4i square minus 10i plus 9. I square is minus 1, no? So minus 4 minus 12 plus 2i by minus 4. Here also 4i square is minus 4 minus 10i plus 9. So it is minus 16 plus 2i divided by plus 5 minus 10i. So now you see, I already told you that you should never get I terms in the denominator. If you have it like that, you multiply and divide by conjugate so that the imaginary part in the denominator will get eliminated. So here I am taking 5 outside, so it will be simply 1 minus 2i. Its conjugate is 1 plus 2i. Multiply and divide by 1 plus 2i. Okay, so what we have, 2 by 5 into, this is I minus 8 into 1 plus 2i by, here it is like a minus ib into a plus ib. For a minus ib into a plus ib, the formula is a square plus b square. So 1 plus 4. Okay, so 2 by 25 into, multiply the numerator, it is I plus 2i square minus 8 minus 16i. Right, equal to 2 by 25 into minus 15i minus 10. Okay, now you take 5 outside and cancel. So this is the final value we are getting. So this is the value of the limit at z equal to minus 2i for the given function. So compare this problem and the previous problem. Can you see the difference? Here for this problem, by substituting z equal to minus 2i, we are not getting any indeterminate form. So we have directly substituted and find out the value. So if you have problems like this, you can directly substitute the value as it is. No need to do any other simplification. Only when you get indeterminate forms like this, in that way, in that case, you try to simplify. Okay, whether you can come out of that indeterminate form and get any finite solution. Okay, if you get the finite solution, it is called the limit. Otherwise, you can say the limit does not exist. Okay, then next problem. Check whether each of the following functions f of z have limit as z tends to 0. So for remaining problems, we are going to find whether the limit exists as z tends to 0. The first problem is f of z equal to z bar by z. Now what is given? Z tends to 0, no? So what is z? Z is 0 and z bar is also 0. So if you substitute it directly here, you will get 0 by 0 indeterminate form. Okay, so what I am going to do is I have to do some simplification. Directly I cannot do anything here. So what I am going to do is substitute z equal to x plus iy. So what is z bar? X minus iy. So I am going to rewrite z as x plus iy and z bar as x minus iy. So what happens to this limit? See, z is equal to 0 means what? Both x and y are 0. Real and imaginary parts are 0. So when you change this as in terms of x and y, this limit also you should write it as both x and y tends to 0. X minus iy by x plus iy. Now what to do? Already I told you, whenever you are finding the limit in complex plane, the point can be approached in any way. Okay, not only along the left and right sides, it can approach in along any curve. So what I'm going to take is this y is approaching 0 along the path y equal to mx. What is this y equal to mx? It is nothing but equation of a straight line with slope m. Isn't it? Equation of a straight line passing through origin with slope m. Why I am taking like this? Now look at this function. This is x minus iy in the numerator and denominator x plus iy. So if you substitute 0 directly here, you will get indeterminate form. So what I am going to assume is one of my variable y is approaching 0 along the line y equal to mx. I already told you, no, it can approach 0 along any curve along any way. So for simplicity, I have taken like this. Why particularly I am choosing this mx? Because here both of degree 1, no? So I am going to replace everything in terms of x. Then it will be easy for me for calculation. So I am taking m into x. So substitute. So hereafter no need to write y tends to 0 because y also I have changed into x, no? So limit x tends to 0, x minus imx by x plus imx. So cancel x from numerator and denominator. Finally what I am getting? 1 minus im by 1 plus im this term is entirely independent of x. So this x tends to 0 doesn't have any role here. So the value is only 1 minus im by 1 plus im. Now this is the value of the limit. But you see, this is randomly I have chosen curve. This m may take any value 1, 2, 3, plus 1, 2, plus 1, plus 2, or minus 1, minus 2. Any value it can take. So whenever you change the value of m, you will get different values, you know. That is not the case. You should not get it like that. Okay, along whatever curve it approaches 0, you should get a single constant value. Then only we say the limit exists. Since this is not like that, this value will change as the value of m differs. This is not a unique value. That means what? The limit does not exist. Okay. Next problem, f of z equal to square root of modulus xy by x plus iy. Here also the same thing. If you substitute 0, 0, both numerator and denominator will get 0. So what I am going to assume here is, I am going to assume, let us assume y approaches 0 along y equal to mx. Y here also I am choosing the same thing because everything is of order degree 1, no? So y along y equal to mx. You substitute, okay, square root of modulus x into mx by x plus I into mx. Now you take x outside. Here numerator x square, no, x square is a positive number, so take it outside. It will be x into root of modulus m by x into 1 plus im. Cancel x, again also you are getting root of modulus m by 1 plus im. This will differ for different values of m. Therefore, the limit does not exist. Okay. Then one more problem, f of z equal to minus I x cube y by x power 6 plus y square, where z is not equal to 0. The same thing, if you substitute x equal to 0, y equal to 0, you will get 0 by 0 form. So here I am assuming y is approaching 0 along the line y equal to mx cube. Why I am taking it as mx cube? Because here I am look at the power here, it is x cube. So the total degree of numerator is 4, but here it is 6. So if I substitute mx cube, it will be convenient for me to do the calculation. That is why I have taken. If you take any other value, you will not get any common factors to cancel. Okay. So by looking at the given question only, you can decide along which curve you are approaching 0. So here I have taken along y equal to mx cube. Now you substitute minus I x cube into mx cube divided by x power 6 plus m square x power 6. Now this x power 6 is common throughout, so I am cancelling. Finally, I am getting it as minus I into m by 1 plus m square. Again the same story. Here this value differs for different values of m. Therefore, the limit of the function does not exist. And then finally last problem, f of z equal to xy by x square plus y square, where z is not equal to 0. So if you substitute x equal to 0, y equal to 0, 0 by 0 indeterminate form. So I am substituting what? That is, I am going to assume that y is approaching 0 along y equal to mx. That means substitute x into mx by x square plus m square x square. Throughout you cancel x square. So it will be simply m by 1 plus m square. Again the same case. What? This is depending on m. That means for different values of m, the limit will have different values. It is not allowed. Okay, you should have a unique value, no? So what we say? The limit of the function as z tends to 0 does not exist. That's all. Thank you.